Hello everyone, today we will continue with the commissioning of our printer. So for that, again I will follow the guide in the voronsdesign.com. I have actually edited my config file. First thing you need to do for that, in the software configuration file, there is already a couple template config files that you can use. In this path I found this spider config for Trident. I am using that one, but I changed a couple things. So first thing you need to do, you need to find your ID of the motherboard with this command in the Raspberry Pi, and you need to replace this ID with yours. So with this name, it will communicate. The Raspberry Pi will communicate your motherboard. Then if we follow it, how do you say it fastly, you will find these options. In the config, it's actually explaining itself. For example, in here, you need to uncommand for 250mm build. So according to your build, you need to uncommand these two section, and the rest you can delete it. And let's go through again. Firstly, same thing in here applies under the stepper Y. So in here, the stepper motors of Z drives. Be careful about the rotation distance. It's pre-configured as a 4, but for example, it was mine was 8. It's most probably written on your stepper motor. You can check it. So if it is 8, just replace these ones in 8 for each Z stepper motor, for example, in here. And in the extruder section, you need to be careful about your thermistor type. If your thermistor type is wrong, you will get wrong values. And we will do the pressure advanced tuning later on. And again, for the bed, you need to replace this one if you are using different one. And for the keynotes, it's mostly 3950, but in the recent clipper, this tag is changed. So it's now generic 3950. So if you are already installed your exhaust, you need to activate this one with deleting the commands. These are the electronics fan. In here, the guys who created the template used LED R output for electronics fan. So you might need to change the pin number. So for the pin number, you can find a screenshot in the Fitex GitHub page. So for example, the LED part is here, LED R is this one, and this is PB6. So with this screenshot, you can, like I said, you can check the pin number. For example, if you put your fan, exhaust fan in here, just assuming in your build, you need to use this pin number. Just check the GitHub page of Fitech, or you can put your electronics fan in here in this connection, and that will work. But I would recommend to you edit your config with your build, not edit your build with the config. Here again, same size, it's explaining itself. Mine is, for example, 300. I just uncomment these and I just delete this one and this part. That's all. And again, for display, if you install your display, and if it is mini 12846, just uncomment these. And yeah, and the Z tilt section, again, you need to select the configs according to your builds. And same thing in here under the bed mesh. And that should be all for now. After that, now we will start with actual commissioning. For that, I will follow this guide. Yeah, and we will start with the stepper motor check. So for Trident, we will use this command stepper bus stepper equals to stepper X, Y, Z, Z1, Z2, and extruder. So just copy this one, and in the console section, we will send this command. At the moment, my tool head is coming front left a couple times. So now we need to verify this one. So we can check with this one. Yes. I'm not sure, but the front left is correct, but I'm not sure. So for now I will continue with the Y motor. So it's the same command, but it's equals to stepper Y. Now it's coming to front right. It's coming front right and going to front right and coming back to its initial position. Okay, now we will do same with the Z motor. I have realized that my pin configuration for the Z stepper motors were wrong. I mean, it's wrong according to manual. So in the manual, it's showing the M5 it's Z left and it goes on. But according to config, template config, the Z left is connected to M4. So what I did, I just went to GitHub page of the Spider and found the pinout. And in here, so these three, the Z stepper motors are connected according to the manual. So this is the M5, M6, and M7. So according to these pins, I edited mine. So you can do the same. So let's now test it again. So I need to send stepper Z. So, and Z is actually should be left motor. Yeah, yeah, yeah. Now my Z is going down and up. So I'm at the moment it's I'm not sure about the directions. I will show you how I'm checking the directions. I'm right now at the moment I'm just checking my motors are working properly or not. Now at the moment with the Z1 the rear motor is moving, so if I can check, so it's the rear one. So my connection and the config is correct. So let's try also Z2 and it should be right. Yeah, if you can see my right motor is going up and down. So yeah, we will continue with the Endstop check. In main sale there are in the machine page there are already a Endstop query, but you can send query via console also. So when I send this one, yeah, XYZ is open. While none of them are occupied, none of them are pressed, it should be saying open. Now let's check the one by one. So right now I'm pushing the X, so X is triggered. Now I'm pushing the Y, Y is triggered. Now last one, I'm pushing the Z, Z is triggered. That shows us my end stops are also fine. So if one of them is showing triggered while it's not pressed, you can easily change invert the pin inside your config. It's shown in here. If there is an exclamation mark, delete it. If there is not, put an exclamation mark before the pin, so it will invert the input. So with that, it should be okay. Now we will do the homing check. If something goes wrong, there is a stop button in the main scene interface. You can use that one, or you can use M112 via the console to interrupt the action, or you can just unplug or unpower your printer, but be ready to do so. For the homing check, first I will say home X. My toolhead should go to the right. So if my toolhead goes to left, I will just press the end stop. I will invert the pin and correct the direction. So let's see. Yeah, exactly. As you can see, my toolhead was going to left. Now I will change the direction of my X motor with putting an exclamation mark. So I will now saved it. Let's restart it. And yeah, now it should go right. No. So it should stop it. Yep. Now my X is home. So what did I have changed the direction of the stepper X and stepper Y. So now I will try to Y again. I will be ready to press origin stop. So the direction is correct. And yeah, at the moment my printhead is found the home position for X and Y direction. Now what we need to do, we need to do the bed locating. Actually in V2 you have more room to play to place your bed, but in V2 since there is a 3-point connection, so this 2 will not allow you to move your bed in the Y direction, and this one will not allow you to move your bed in the X direction. I mean, there is always playroom. However, uh, it's not that much. But again, we need to do that. So let me do that and see you in a bit. For the positioning bed, you need to position your Z Endstop. So basically, just home your tool head in the X and Y, then move your tool head in the Y direction like this. So for the bed locating, just home your tool head in the X and home your tool head in the Y direction. Then after that, in the help of this control page, move your tool head approximately top of your Z end stop. With that position, adjust your Z end stop position. You know, it's only adjustable at the Y axis. So just with eyeballing, align the pin with your hot end tip and tighten the screws of the Z end stop and fix the position it. And after that, there should be at least 2 millimeter gap between the pin and your bed due to prevent the heat transfer to your end stop. Put this space between your end stop pin and your bed, and after that you can just screw which are holding your bed to the frame. But I didn't tighten my screws. I suggest the same to you because first I want to heat my bed. I want to do the heat soak. So the up with heat, you know, the aluminum has a extending a bit, so moving a bit. So after that, after heat soaking, I will tighten my screw and I will not, I will just slightly tighten it and leave it like that. So for now, it's okay. In the next step is defining 0.0. Actually, this is like teaching your printer where your bed is. So for that, we need to home our tool head in the X and Y axis, which we already did. And so we will bring the tool head the front left. So for that, we can use that control part. So this is the normally your 0.0 position. So again, you need to eyeball and you need to match your hot end with the corner front left of your printer. But like I said, I will not tighten it for now, so I will pass that part. And yeah, you can just, if there's a difference, you can just measure it. For example, let's assume there is a difference in the x-axis, like a 3 millimeter. And with that formula, you will get new value. And this value needs to be changed in the position max in your config. So stepper X, here it is. So it's the position max. Now we will find the position of our Z and stop pin. So for that we need to home our tool head in the X and Y direction. Now again with the help of controls, I will just find the position of the tool Z and stop with eyeballing. in here, in that part, we will update our values 173 and 300. Save it and we will restart our printer. Now, I was just checking my uh, is there any extra room in my printer? So at the moment, for example, my Y is at 0, but it's 0 in the software. But there is still playroom in here, like a 5 millimeter, 5 to 10 millimeter. So that means I can gain 5 to 10 millimeter in the back, so I can use that part also. But those I will do, like I said, after everything is finished and while I'm securing the bed. So for now I'll pass that one. So now we can try to full homing, but again be careful. We might want to interrupt after homing by also it should went over to that Endstop pin to home in the Z direction. So eyeball it. If it is not matching, yeah, like me. So at the moment it's not matching. Basically I just tweak the position of the Z Endstop and now it's homing like what we want. Okay, now the next one is we need to test our probe. So for that, I will suggest you to use something metal. And if you observe the probe, there is a red light which you cannot see via camera, but you will see on the real life. So if the red light is going off and your metal part is next to it, your probe most probably should be fine. I mean, at least it's fine to test next. So you can do also query probe. So at the moment it's open, but I will try with this one. Yeah, as you can see, it's triggered. Now it's open. Now we need to do the accuracy check. For the probe accuracy, we need to home our printer first. For probe accuracy, we need to home our printer and bring our tool head in the middle of the printer. Then we can send this command. Okay. So now it will do the checking and it will do the calculation for the deviation and etc. and it will give you the results. So like you can see in here. So the standard deviation should be lesser than 0.003. In our case, it's 0.001. So that seems fine. So if it is less than 0.003 millimeter, then you'll be fine. Then we will start PID tuning. Now, I don't have the enclosure, so that's why I will do it without enclosing my printer. But if I had the pieces, what I will do, I will just put all the panels and I will just do the heat soak, and after that I will do the PID tuning. Because I was thinking it is that the working environment of your printer will be a hot environment inside the printer. So mostly you will use your printer in the closed chamber, as I'm guessing. If you are printing PLA, it's a different story. But what I'm trying to say, just try to simulate the most used condition in your case, and with that do the PID tuning. But since I don't have the clips and all, I will just now do the PID tuning as a temporary. But after that, like I said, I will, after changing everything on the printer for the printed parts, and after enclosing it, I will do this PID tuning again once more, and I will use those. So, but now, yeah, for the PID calibration. Again, you can use this code. And yeah, we will do the bed and target is 100. Since I will use ABS, I will use my bed at 100 degree. So I will calibrate it as a target in 100 degree. So this take a time a bit. Now PID tune for the bed is done. Now we need to send save config. So it will save this parameter in our config file and restart our printer. Now I will set my bed to 100 degree again. So I will keep it like that for an hour or two, and after that, like I said, I will slightly tighten my screws on bed. So now what next? We will do the same thing for the extruder, but for that we need to run our cooling fan at 25%. For that we are sending this command. So and again we will use similar command, and yeah, you can change this target value if you are printing mostly at, for example, 200 degree, for example, for you will print PLA. Just tune your PID with that value. So 245 is fine for me, so I will run it like that. Now it will do the same thing, like I said. So see you in a bit. PID calibration for Extruder is also done. We will do the same and save these values. In my config, the max temperature for the extruder was set to 250, so that's why it's interrupted in the first try, so I had to reinitiate the calibration. Now we will continue with the bed leveling, so that means our printer should level gantry automatically. So depending on our printer, we have a couple options. So for the Trident, we will go with Z tilt. So for that, we need to send Z. Oops, we need to send Z tilt adjust. I don't know it's homing. Yeah, okay. So we need to home our printer first. Yeah, at the moment I could manage it. The thing is my horizontal Z move settings 10 was not enough, so I increased to 15. Now it's probing the points to do the bed leveling. Now it's taking measurements. So it's make the adjustments. Now, so in here you can see it's made a couple adjustments. Now doing the second run. Yeah, since my horizontal Z move is now 15, it's taking a bit longer to take the measurements. So yeah, it did the second calibration. Now it's measuring for the third one. Yeah, it's done. Yeah, till now everything's working. Now the next thing is Z offset adjustment, and it's the before doing that, I will do the extruder calibration because I will do this calibration uh, with my nozzle off. With my nozzle is not uh, plugged. With my nozzle is not mounted. For now, I will change my minimum extrusion temperature to 0 to be able to extrude some filaments. Okay, so I need to change the direction pin of the extruder because when I say extrude, it's actually retracting. So now it should, yeah, it grabbed the filament. Now what we need to do, we need to measure 120 millimeter from the tool head. Now we will extrude 100 millimeter. So this is 50 and this should be 100. Let's, now we will measure the remaining part. So yeah, it should be 20 and it's 20 in my case also. Yeah, in my previous Vorons also I didn't change the calibration of the extruder, but it's worth to check. Now I will unload the filament. Yes, and now we need to do Z offset thing. Now we need to heat our hot end also, so let's start with that. And there should be Z up, Z down, by the way. So first we will do that with the paper. Yeah, for that you need to do the PID tunement and your bed should be at 100 degree and your nozzle should be set at 245 and at least we need to keep it like 15 minutes to do the heat soak. So I would suggest more, at least for the bed. Okay, extruder it's easily for the bed. So keep it at 100 degree for a half an hour or 1 hour or so. Then after that do the Z offset. So let's, now it's around 240. So let's wait 15 minutes and do the steps in here. Actually, while waiting the heat soak, we can try bed mesh. So for that, it's already defined in config. So first we will do home. Now we will do the Z tilt to make our gantry flat. We will do bed mesh calibrate. So Z tilt. Speed, Z tilt speed. By the way, I didn't grease my lead screws yet, so that's why it's squeaking. I will do that after this commissioning is finished. So I would suggest the same thing to you. Yeah. So it's defined as a 5 by 5 by the way, so it will measure 25 points in our bed. So let's wait. Now the measurement is done and we can see at the bed height. This is the front of the bed and this is the left side. So I think I need to play with the frames which are holding the gantry. For the left side, I think I need to move just 0.1 millimeter up, and same for this one, and 0. Approximately 17 millimeter up in the front right corner also. Besides that, it seems fine. So yeah, this bet from the Fermio, by the way. This time I got from the trusted seller for the bet because in the form bot it was taco. This is the next thing I need to fix. I think it's been about 15 minutes since my hot end is 245. So in here for that we need to run G28 and the Z tilt adjust. Since I did the bet mesh, I already did. We will move our tool head at the middle of the printer. So if let's boost it. Yes, and we will send this command and I will prepare my paper. Okay, so we will send this command. I will move my tool head since I have a 30 millimeter gap approximately. I will send it down at a 10. I can do another 10 and I will reduce it to 5 now. Another 5. Yeah, now we'll do 1 and check my paper. Okay, now it's grabbing. I will lift up just 0.05 millimeter. Yeah, this is nice. Your nozzle should grab your paper a bit, but not too much. So since Clipper assumes that this procedure is done while our printer is cold, we need to add another minus 0.1, copy 0.1. We will send accept and we will save this config. Yeah, and our Z offset is also done. You can also print a file and do the live Z tuning while you are printing in the first layer and save this value and the config. And yeah, we are done actually. That was all for the commissioning. Basically, our printer is ready to print now. And yeah, thank you for watching and see you on the next one.